Yeah. So, hello and welcome back again. Today we are going to talk about another thing in 11.4, which what is talking about how to sketch the graph in 11.4. We see that before that is important. Why? Because for area we need it. For 11.5, it's a preparation for 11.5. And both of them, they have a question in the final. So be careful and pay attention. We say that, for example, how to find the symmetry. I just remembering you. And we see that we have three symmetries. We should test them. And I gave you two important notes: symmetry about X, Y, and origin. In some books or in some websites, they say symmetric about pi over 2 line instead of Y, or they say symmetric about origin with the same origin. Also, sometimes they say symmetry about theta is equal to 0, means that X axis. So they are the same, you know, that one. The first, and I gave you two important notes about if I have two symmetry, we see buy two, get the third free, right? So if you have two symmetry, the third is automatically, we have it. If I have one and I don't have a second, so sure, if you are in the right situation, be sure that the third one is not be possible to be symmetry. So that's all about that one. And as well, we mentioned derivative on the for polar as well. And I remember we sketched the first graph in here. We put the point by point and we discussed how to sketch it, because we say that this graph is not equal to that graph. We say that this graph is not like that graph. Why? Because when we sketch it, I sketch it like that here. But that one, no, it was like that. So it will make a difference, especially for finding the area, make a difference. Maybe if you are controlling all of them, maybe you control them, and then you see they are not different. But for now, it's make a difference, so be careful. Put a point, be careful how to start with that point, and that point, and that point, and that point, and that point. And we sketch, I remember that. And I promise to give you some formula to help you to control all these graphs, because actually in your exercise there are many shapes, and we are going to focus on 3 or 4 of them. So that's all for what we need. The second example here, I'm going to use the classic way again before give you the the clue, or before give you the easy way. I'm going to give you the harder to learn how, because if you control the classic way to sketch, then later you know how the easiest is like that. So we have r squared cosine theta. Student, before start, we say what we should think about the symmetry, right? Because I have a cosine in my mind is what? The symmetry about what? X-axis. You are right. We say that before in the previous lecture. See, if you have a cosine y, because we say, for example, we have r squared is equal to 4 cosine squared for cosine theta, right? It's like that. Yeah, good. So we see that first of all, to sketching, we have A and B. Now remember, A1 is what? Symmetry about x-axis. So for that, we say r theta should be changed to what? X-axis, r minus theta. Do you remember that? We are here. My point is here. R theta should be come to here. So I say r minus theta, right? The same. So for that purpose, because I have a cosine, I am 100% sure about that. If I have r squared is equal to r cosine theta, which is my origin one, you remember that. We have a what? We should change r is the same for cosine minus theta, right? And you know that one will be what? R squared cosine theta. So I have what? We remember that one as a star. And finally, we see compares origin with the star. If they are equal, it means that symmetry, otherwise is not. So it's symmetry, right? How about the second? I'm not going to y-axis. Why? That's why I say sometimes tricky. Use the trick way. Why I'm not going to the origin, the y-axis? Because I have r squared, and in my mind, because I used a lot, I say about what? Origin. Symmetry about origin. Why is symmetry about origin? Because I say r theta will change to what? minus r theta. You are here. You want to bring it to here. So r theta, you see, is minus r theta. Nothing changed. So I'm going to just change the r, and I'm sure about the r squared will make the same. So r squared 4 cosine theta will change to minus r squared 4 cosine theta, was equal to what? R squared cosine theta. Instead of going to y, maybe if you are going to y, you get a problem. You cannot solve. You should use the other one. Theta minus pi minus theta and with minus r. So in that case, instead of that one, go to there and you say the same. So they are equal. So about also origin. Now, how about y? We have what? X and origin. So we get y also. You know what I mean. I wrote that one because I'm in a hurry, but you can say x-axis and origin. So then by the note, we will get the third one. So it's symmetry about everywhere, right? Now A is finished by 2 seconds, by 2 minutes. Let me see. 2 minutes, right? So it's easy because you don't need to apply all of them. And tricky way, use the theta cosine. I'm going to x r squared. I'm going to origin. Now you have a more information about it. Understood? So tell me about the angle. I should take a points or important point. I think something like that. So which point is important for me? I have theta, I have r, which is equal to r squared 4 cosine theta, and I have what? Yalla, I have what? R and theta, right? Yalla. In your mind, which angle I should take? 0 to where? To where? Pi over 2. You're right. Thank you. Why? Why till 0 to pi over 2? Why? You're right. Because? No, because symmetry about everywhere. So if I have a graph in the first quadrant, I can copy to the second, to the third, to the fourth, right? Or to the fourth, to the third, to the up to you. If I have a symmetry about everywhere, if I have a graph here, so I'm sure about that one, that one, that one. Here by x-axis, here by y-axis, here by origin. So which one is important for me? First quadrant. How about if it's only about x-axis from 0 to pi? Because any graph here is the graph here. You got it? Hello? Good. So that's why, now you have information. Good for you because you are close to scale the graph. So evaluate so substitute the value, cosine of 0, 1, 4 by 1. So r equal to what? Am I right? So just write 2 and 0. Okay. And later we have a minus. How about pi over 6? Is equal to what? 1 over 2? No. Cosine or sine is equal to 1 over 2. I don't know. So I'm going to use the table again. I say 1 over 2. So square root of 3 over 2, 4, right? R square equal to that one. So R equal to what? Forget about that one. Let me change it to 2. So at some point I cannot sketch it because rational. How about pi over 4? You have 4, 2 square root of 2. Am I right? 2 square root of, again, R equal to what? Square root of that one. So again is not a good value. How about that one? It's easy. 1 over 2. Am I right? So it remains what? 2. So R equal to what? square root of 2. Am I right? So positive, negative, square root of 2 with pi over 3. At least I have something. And pi over 2, 0. So I have what? 0 and pi over 2. So how I scale that one? Look at here. These three important. At 0, I have 2 and what? At the same time, 2 point. 2 point. Why? Because it's a square. So 0 and minus. Okay. How about the next? It was, I don't know, something here. I don't know, something here. And at pi over 3, 60. So I'm here, square root of 2. Square root of 2 is equal to what? 1.4, right? So it's not 2, 1.4, something like that. So here, I have 1.42 like that. So I think if that one is 2, here's 2, here's 2, that one will be 1.4. Am I right? That one was the angle, pi over 3, sorry. So that point and that point in my mind. And how about 90? 0. On you? Pi over 2 is 0. So this point will be 0. So I have 3 important points. Let me sketch it. I have 3 important points. That one, and that one. So maybe here's another point, right? So I'm going to by the way, I have the same things here. Because S square, R square. So if I check that one, from here is going to be 0. And I know it's a curve because we have a sine, cosine. We know it's like a wave. Maybe you say, why is not like that? Because, you know, we have a sine or cosine. So it looks like a curve. That's why I'm going to sketch it to the other one, to 0. So from 2 to 0. Do you have any problem? And the direction is like that. Am I right? And at the same time, the direction is like that. You got it? Hello? Good. So because of symmetry about x-axis, yeah, I have that one. And because the symmetry, that one. Because the symmetry about y-axis, I have that one. And you can say, even you didn't think about that part, you can say because of symmetry about origin, which color? Red. Because about symmetry about y origin, I think a little bit clear, not more. Maybe 40%, right? Is enough 40%? Do you agree? No? More? 100%, no. I don't expect 100% at the beginning. So that's good. So now I'm going back to my graph and look at here, look at the, I cannot get that one by calculator, I will get it. I cannot get that one by calculator, but that one, it was a little bit close because we say square root of 2, you remember. So the 1.4 something is okay. So these three help me to sketch what? To sketch the graph. And you can see from here to there, from here to there, you have it. Understood? That's all what we need to find it. And it's easy, but maybe the shape a little bit different. It looked like a 2 circle. It looked like a, what do you say, infinity, 2 circles or infinity, but it looked like the same, right? So maybe a little bit wider, expanded, it's okay. Generally, it's okay. So that one is not include. The example is include, but the way is not include. Look at these names, okay? And of course, that one is not using technology, means that using internet and computer, so we don't need to. But to sketch something like that, how we sketch, I add something for you, I remember. Let me bring it from my Google Classroom. Yes, last night I downloaded something for you, right? You got anything? You got it? Let me check. Actually, I updated. In the previous year, it was a little bit, but now I updated for you to give you more. I don't know why Thomas didn't mention something here like that. I don't know why. Because actually Thomas is a great book and they didn't mention this way. I don't know why. Maybe they say they are clever, right? Okay, let me download it and deal with these situations. Come on. Okay. What's going on? Good. So now we have a formula and a graph. During the exam, I'll bring one of them. Already, actually, this one extra is not in your lecture note. You can print it separately. For example, in the exam, I will give you this example. I say sketch this polar. Let me R 4 sine 2 theta. You didn't see that one before, and actually it's not easy to do it directly or by the previous. Maybe you know the sine is symmetry about y-axis at least, and you don't know about origin or not, so you need to spend more time. For controlling these to get the shape before sketching. For example, if you saw that one, you see this is 2, so it means that I have 4 leaves. So how before you do it, and you know that one you need to from 0 to pi over 2, and you know this one is symmetry about what? About all of them, and you know to start from here to there to there, then you can sketch it. At least before you are starting, you know how to start. You know what I mean. So for that purpose, I'm going to give you all these shapes. The first one, if we have what? We have r a cosine theta or r sine theta. R equal to, first shape, a cosine theta, let a be any number. So in that case, we have a circle over x-axis. So symmetry about what? About the x-axis, and we have a circle over x-axis. You know, we copy and paste the polar on what? On Cartesian to get more information, or to make it easier for you. And if that one, this a is minus, for example, I have minus 3 cosine theta. You say cosine theta make a what? Make a circle. So the circle will come to here. Understood? By minus. So before you are starting the graph, you know how to get the shape. That's the one. And you know it's a symmetry about what? X-axis, right? You don't need to. It's not symmetry about y. It's not symmetry about origin, right? So it's easy and it's clear. You get the idea, dears? How about if I say r equal to 2 sine theta? Look at here. Theta is 1. R is not square. Theta, the angle is only 1. Only theta. So how about that one? We know is going to be y-axis or positive y-axis. Here, the shape will be like that. And you know is symmetry about what? So you can take from 0 to pi over 2 and you copy and paste it, right? Understood. How about if I change that one to minus? Up to down. Now, if I have r plus minus a sine theta or cosine theta, I know 100% is a circle, right? And circle is what? Over x, over y, over one of them. You got these 4 shapes? How you got it? Good? Okay. You can take a rest if you are feeling tired. Now, for example, how to scale that one? So during the exam, When I say r equal to 4 cosine theta, you don't leave it like that for me. You will get nothing, maybe 1 over 5 over 10. You know what I mean? You will go, or your steps should be what? About first symmetry about x-axis, y-axis, but you know. Before you do mistake, you know the result. So you know the symmetry about x-axis, okay? It's not symmetry about y-axis, as well as not symmetry about origin. And the graph, the points, important point is start from 0 to pi, and you have a table for me, and you sketch the important point, then you sketch the graph like that. Now you know what I want. Understood, Kaka? Understood? Good. Clear? But before you do it, you know. Symmetry about what? Okay. Next example, and here's the details about the x-axis and things, and here's the detail from 0 to pi and how you get these important points. Good. Now, and here's the graph from 0 to pi, we got that part. Okay. Next, cardioid. The cardioid shape. So we have 3 shapes in the cardioid that look like a cardioid. But when they are equal, we say cardioid. When they are not equal, we say dimple. When they are not equal, we say limicon or lemniscon. How? The shape is like that. Look and listen. A number, plus B cosine theta. Of course, sometimes that one will be minus. Of course, sometimes that one will be what? Sine. So I have 4 shape, but all the same. For example, 2 plus 2 cosine theta. I think we saw that one in the previous lecture. So I say because I have A and B, absolute A, absolute B, without counting the relation between operation between them. Just I want A and B. Okay. I say A plus B equal to what? First of all, I say the shape is like that. Understood. But here is equal to what? Here is equal to what? That's the question. Here is equal to A. 100%, and that one will be A, maybe minus pi over 2 or any numbers. Understood? So the important point is A. And here's A plus B equal to what? Equal to 4, right? So this point will be 4 and pi. Because I know this shape is symmetry about x-axis. So my angle start from 0 to pi over 2 to pi. 0 to pi. Why? Because it's symmetry about x-axis. So that one, the point 0, 0. That one is 2 pi over 2. That one's 4 pi over 2. Without calculating anything, without starting, you know about it. How? I'm going to give you again. That one will be A. That one will be A plus B. Now, how about if I have R equal to 2 minus 2 cosine theta? The shape the same, but in different way. I say that one A, that one B. So I say A is equal to what? 2 and pi over 2. How about that one? I say 4 and pi. Again, 4. So A plus B equal to what? 2, 4. You get the idea? So tell me about symmetry about X or not? I don't know. Is 0? So that point is to be what? 4. Thank you. You're right. How about this point? 4 and pi? No. 0 and pi. Yes. Put pi here, you'll get minus 1. Minus minus will be 4. So yes, you make a mistake. Kaka. Let me do that. I'll do it for you. Wait, just wait, okay? To be sure that when I am right or not, we say 2 minus 2, right? Okay, if I put pi here, I'll get what? Minus 1. Cosine of pi is minus 1. So minus 1 will make it what? Plus 2 plus 2, 4. So I get 4 and pi. Here's 4. Right? Understood. Good. Does it be like that? No. No, so it means that I made a mistake with the shape. Wait. That one should be in the other side. Wait. Now that point is what? 4 and pi, right? Now it's right, you're right. And how about the, so let me see, what did I do? No, that one is a mistake. Sorry. The shape of here, like that. So that point, I'm going to review that one again for you. Both of them, sorry. So first we say 2 plus 2 cosine theta, right? So we see the shape, I don't know, maybe that like that or like that. So I did a mistake. It should be like that. How? Let me put 0 here. I'll get what? Cosine of 0, 1. So 1 multiply 2, 2. 2 plus 2, 4. Right? 4 and 0. How about that one? A. So this is A plus B. Came from A plus B. How about that one? 2 and pi over 2. How about that point? 0 and pi. Thank you. 0 and pi. Why? Because if I put pi here, I'll get what? Minus 1, right? So if I put pi in here, I'll get what? I'll get minus 1. Minus 1 multiply 2, minus 2. 2 minus 2, 0. Now it's correct. Now the second part, the second shape, I did a mistake by the shape. It's okay, you can control it like that. You see that one is what? 2 minus 2 cosine theta. Let me study the angles. We are going to study the angles. Okay. So give me the points by red. If I put 0 in the angle, I'll get what? 2 minus 2 equal to 0. So 0, 0. If I put 4 pi over 2, I am sure about 2 and pi over 2. How about that point is A plus B, means that 4 and pi. How? Because if I put pi, I'll get negative 1. Negative by negative will change to the positive. So 2 is equal to 4. Now everything is correct. You got it, dears? Okay, the important thing is shape. So if I have a plus or minus, AB should be equal. Cosine theta, I'll get for positive part, I'll get like that. For negative part, I'll get something like that as called cardioid. How about sine? Yalla. Careful, A and B are equal. How about sine? Yalla. Your expectation? Same, no. Over y-axis, you are right. So maybe we have that one, or maybe we have that one. Yalla. Tell me about 2 plus 2. So 2 plus 2. So cosine of pi over 2 is equal to what? I'm going to pi over 2 or 0. So I'm going to put 0. If I put 0, I'll get what? Sine of 0? 0. So here will be what? 2 and 0. Am I right? Of course, we say A. You remember. How about here? We say A plus B is 4. 4 with what? I don't know. Let me check it. If I put pi over 2, I'll get what? 1, right? So that one will be and pi over 2. Understood? So this shape is not. Understood, dears? So that one will be 4 and pi over 2. How about that? The graph of this one is what? Here's 2 with something. Here's 4 with something. So tell me that something. ليه جماعة? Just angle. Yes. Let me put 0. I'll get what? 2. Yes. 2 minus 0. Okay. If I put pi over 2, I'll get what? Pi over 2 is equal to 0. So that point will be pi over 2 and 0. Am I right? So how I get that one? Hello? This point is equal to what? Tell me. Kaka Sardar. Now it's participation class. Well, see why I asked that question. So this point is equal to what? 3 pi over 2. Why not? Why 3 pi over 2? Because 3 pi over 2 is equal to minus 1. So minus 2. 2 plus 2, 4. Or you can see what? Am I right? Pi over 2. Come to here and with 4. So it depends. Generally, we said about that in the 11.2, 3. Here we mentioned that one. So you can find the value and it's easier for you. Now tell me about symmetry. Now it's time to sketch to write your steps. A, symmetry about X. No. Y. So how about origin? Y. 1 no. So the third will be no. So how about points? This is important points. How about the graph? This is the graph. So do not forget about 4 and 0 and A. This is the cardioid shape. Do you have any question? No. How about, here's the example. Sketch that one. Here's the symmetry. Here's the important point. Look, 0, pi over 2, 2 pi over 3. This point is clear. You can get the R's. But I don't ask you about that one because I know you need a calculator. But already you know the shape. Good. How about limacon? Loop with the limacon. It's better to call just limacon. No, I told you. I just say sketch. Done. You should recognize it with shape. You see that one as dimple, for example, in your mind, and the shape is like that. Okay, then you will emphasize the important points here, there, and there. And you are going to sketch it. How? Symmetry. With X, Y, origin. Then the second important point, C shape. But before you are doing, you have C. Already I gave you. You have it in the class, right? Not in the exam. This is your question. Nothing else. It's easy. Try to do it 3 or 4 times each one. You'll control all of them. Understood. And 100% one question is like that. And it's not something to skip it. Say I'm not going to understand. Do not skip it. 11.4, 11.5. Do not skip it. Understood. Clear? Good. Now limacon is like that. AB cosine AB minus. Plus is like that. Minus is like that. Okay. And sine plus sine minus. But what's the difference between here and the previous one? Look at the example. Here. In the previous, we say A and B are equal. Here, A greater than B. Okay? You got it? So A is greater than B. How? For example, I say R equal to 4, 3 cosine theta. In the previous was 2, 2, 3, 3, 4, 4, 5, 5. Okay? But here, no. 4 plus 3. I have the same idea. I say what? I say the shape is like that. Not like a heart, like a previous one. Yeah. But here is 4. Why 4? Because A. Understood. Here is what? Tell me. A plus B? 7. How about here? 1. Thank you. Why 1? A minus. And we don't care about the value or the sign of A and B. We say 4 and 5, 3. There's what? There's one difference, one unit. So I say 1 and something. So tell me about the somethings now. Yalla, guess it. It's easy. So let's start with 4. If cosine of 0, right? So cosine of pi over 2. So how about here? Cosine of pi. So 4 minus 3 equals to 1. Understood? So this is the important point. Now it's time to answer. Tell me about what? Symmetry about x? Tell me about important points. Tell me about the graph. I think it's easy. If I change that one to that one. Yalla. Quick, it's your turn. Shape. Khera. Yes. Yes. Am I right? The shape is like that. It's not like that. Careful. Okay. So tell me about the points. Okay. Quick. Here, and here. Here's equal to what? 6. No, not minus. 6. How about here? 4A. How about here? 2. Thank you. Now I'm happy because you are with me. So yalla, tell me 2 with what? If I put 0, I will get 1, so you are right. If I put pi over 2, it's not time to deal with that pi over 2 is clear. How about 6? Pi, let me say pi. Yes, you are right. Understood? Clear, dears? So that even I change it to the minus, nothing changed. The idea is that, but the shape instead of that one is going to the other side and vice versa. Now try to do that one at home. Look at here. Sorry. You know symmetry about y-axis, and you know the important points here. Maybe that one is also help you. Okay, because I have a 3 and 4. So of course, 3 and 4, I have 1 and 7. I have 1 and 7. It's very important. So, because the negative, I think, yeah, there's negative between them. So it's going to down of y-axis, right? The shape is going to down of y-axis. So here will be 7. And if I give you even the graph, you can imagine the equation. I have a 7, so it means that 4, the shape of 4 and 3. I have here is minus, and the shape is sine of theta. This one is 4, this one is 4, A. That one is 7, A plus B. And that one is 1, A minus B. Easy, Kaka? Guys, girls, everyone? Good. Try to solve that one. Now, the same shape in the cardioid and the lemma cone, we have what? We have linear. Actually, that one is called dimple or one linear. Sometimes it's called dimple. It's called dimple sometimes. A Lima cone is like that. They have an inner loop. And we are going to use this inner loop in the area. I say find the area of the inner loop. Means that just find here. So if you don't know what's the inner loop, you don't know where we are going to talk about how to find the area. So careful from here. Okay, now, what's the difference? The same shape. We have R equal to A plus or minus B cosine theta. But here is what? Here's B greater than A. What do you mean? R equal to 3 plus 4 cosine theta. As a shape the same, but we have a seed, we have a loop, inner loop. You got it? So symmetry about the x-axis, right? About y, about origin, no. B, important points. Where's the important point? I don't know. You should tell me. Yalla. That point is equal to what? 7. Good. Well done. 7 and something later. That point is equal to 3, 4. How about 3.5? Because sometimes we say A. Do not stop on it. We say A. We don't need to think about it. How about here? How about here? Yalla. Huh? No, tell me about the unit. 1. Thank you. I will tell the other outer loop. 1. That one inner loop. 1 or 2 depends. There's a difference between A and B. Units, not single, not symbol. Okay. So if I put 0, I'll get what? 7. Am I right? If I put pi over 2, that one will be 0, and I'll get 3. Understood? So tell me about 1. I'm going to leave that one for you. 0 and something. Tell me about 1. Pi. If I put pi, I'll get what? Exactly. So pi and minus 1. Pi and minus 1. Pi minus 1. Come back. صفر where? The angle. Okay. Okay. حاوت here. حاوت.
I know. But like, then we will find it. We put in the
We see that one minus 1. Yeah. We say 1 unit. Later we see it minus or plus. We say that because you don't care. We say about the unit. Then later we will have when I put the because my graph is symmetry about x-axis. So from 0 to pi. The important thing is 0, pi over 2, and something else, right? So when I put 0, I'll get 7. When I put pi over 2, I got 3. When I put pi, I got what? Minus 1. So it means that my graph is like that. 0 and 7. Start to here, start to here, start to here. What? 0, 7. And here is what? 3 and pi over 2. And go 91, 92, 93, 94. Tell something that I make it a homework for you because next lecture we need it or next week. So you'll get 0 and something. Then plus that angle. For example, if I say 95, let me say 95, 96, 97, you know what? Then tell 99 and no, 177, 180. So I got what? Like that, and like that. So I got minus 1 and understood? For example, here, if you ask me about this point, I say is equal to minus 0.5 and 90, 100, 70, for example. You got it? So 170, okay, and minus 100, like that. You got it, Jamaat? Hello? Today we just like a calculator, we are like a computer, we don't do anything, just we imagine. So that will be my graph. So from 0 to pi will give me this, will give me this shape, no more. Look. How about the first one, cardioid? It was like that. Am I right? Am I right? Like that. How about dimple? It was like that. But how about in-ear loop? No, it's like that. We have a loop in one round, in one, let me see, in one symmetry, in one from 0 to pi. So how about the positive is here? How about if I have a negative, the same thing, but I like that, started like that to here. How about a sign is like that? How about cos minus sign is like that? So tell me about this graph. Yalla. Don't sleep, be with me. Use your mind. I know you are tired because you didn't do anything. 1 week you just read the news for me. So please, yalla. Dekaka. Just tell me about the point. That's positive. Yes. To the right side. Okay. So I have what? Here's the shape. So I have what? 2 plus 5. So equal to what here? How about here? 2. How about here? 3. All right. A minus B. 5 minus 2, 3. So maybe 3, maybe it's minus 3, we don't know. So, you know, minus 3 and pi, 0 and 7, right? 2 and pi over 2. Yes. So now I have the shape like that. And I'm going to continue. You got it? Hello? Look. I'm sure about the x-axis, polar x. And I know this point is very important for me. Well, it's not important. That one is important. Right? Minus 3 and pi. That one. So here's the graph. Start from here to here to there with homework. Do not forget about homework. Till here. So tell me about 0. Yalla, let me solve that homework together. So how I get 0? Are you sure? You didn't mention it here, but I don't know. Let me homework. Find it. That's okay. But for 5 actually is hard. But for 2, maybe. You know, solve that one. Let homework be like that, Jamaat. Your homework be 3, wait, 2, yeah, 2 minus, sorry. 1 minus 2, let me think about it. Cosine theta. That one's easier. Right? You know 1 over 2. Cosine of 1 over. So that's on homework. So tell me, after sketching, tell me how I get 0 and something. The angle theta should be what? That's your homework. Later do it. I know you did it. Or later answer. We finish a part, but we did another part. Okay. So I'm going to give you